Today, we will perform an interesting activity to verify the formula for surface area and volume of a sphere. The surface area of a sphere S is given by 4 pi r square and the volume of a sphere is given by 4 by 3 pi r cube. To prove the formula, let's determine the surface area and volume of a hemisphere. So we'll have to prove that the surface area and volume of a hemisphere is equal to 2 pi r square and the volume is equal to 2 by 3 pi r cube. In case of a sphere, these values will double because we know that a sphere is made up of two hemispheres. Let's begin by drawing a semicircle of radius 8 cm on chart paper. We'll mark the center of the circle as X. From the center X, let's draw a vertical line touching Q and name it XQ. Let's label the semicircle as AQB. Now we shall divide the semicircle into 8 horizontal strips of height 1 cm each. Let's name the strips starting from the vertical line XQ. Strip 1 is XBCD. Strip 2 is CDEF. Strip 3 is EFGH. The fourth strip is GHIJ. The fifth strip is IJKL. The sixth one is KLMN. And the seventh strip is MNOP. And the last strip is OPQ. Let's measure the length of each of the strips from the vertical line XQ. XB is 8 cm, CD is 7.9 cm, EF is 7.8 cm, GH is equal to 7.4 cm, IJ equals 6.9 cm, KL equals 6.3 cm, MN equals 5.3 cm, and the last strip length OP equals 3.9 cm. We have used these 8 values as the radii to draw 8 circles on a thermocol sheet of 1 cm thickness. Here are the 8 circular cutouts. We have used different colors to distinguish them. With the common center X, let's place the circular discs one on top of the other. What do you think the combined area of these circular discs represents? Yes, it represents the surface area of the hemisphere AQB. Let's do a little calculation to find out the area of this hemisphere. We have tabulated our observations. Let's have a look at that. We know that the formula to calculate the area of a circular disc is S equals radius into 2 pi into thickness of the disc. We also know that the thickness of all the circular discs is the same, which is 1 cm. Substituting these values in the formula, we can determine the surface area of the hemisphere. Adding these values, we get the total surface area of the hemisphere AQB as 107 pi centimeter square. Let's label this value as the experimental value. Let's now determine the area of the hemisphere theoretically and compare it with the experimentally obtained value. We know that the surface area formula is 2 pi r square. The radius of the semicircle we started with was 8 centimeters. Substituting the radius equals 8 in the formula, we get 2 into pi into 8 square, which is equal to 128 pi centimeter square. We observe that these two values of the surface area of the hemisphere are in close approximation. Hence, this formula of the surface area of the hemisphere can be used to arrive at the formula of the surface area of the sphere. Surface area of a sphere is twice the surface area of a hemisphere. So, surface area of a sphere can be calculated using the formula 4 pi r square. Having determined the surface area of the hemisphere, let's now verify the volume of the circular discs. The formula to calculate the volume of the circular discs is given by volume equals r square into pi into thickness. Since we already know the radii and the thickness of the discs, let's go ahead and substitute the values in the formula. Adding these values, we get the volume of the hemisphere AQB as 372.61 pi centimeter cube. This is the experimental value. Let us now calculate the volume theoretically. The formula is 2 by 3 pi r cube. Substituting the value of r equals 8 centimeters, we get the volume equal to 341.33 pi centimeter cube. Comparing these two values, we can conclude that they are in close approximation. So we can double the formula of the volume of the hemisphere to arrive at the formula for the volume of a sphere. Hence, volume of a sphere is given by the formula 2 into 2 by 3 pi r cube or 4 by 3 pi r cube. As you can see in this activity, we obtained two sets of values each for surface area and volume of a sphere. One value was obtained experimentally and other obtained using the formula or theoretically. Both the sets of values were in close approximation. Hence, we can double the formula of the hemispheres to obtain the formula for the surface area and volume of a sphere.